up into the lake, and these things, now has the level of the lake gone down or come up or stayed the same?
Compared to what? Compared to before you put the boat in the water or after you get the boat out of the water? Or
No, that's why I started over. You start the problem where you're sitting in a boat in the lake full of rocks. You throw them in the lake. And you've got to
stay the same.
You're in
The
a
boat doesn't float if it's full of
Mr.
rocks.
Desert IPS science thing where you see out the beaker. Does it rise or lower or stay the same?
That's with ice. That's with ice.
Is it the same?
What do you think about it? You can't just answer it, you got to think about it. In fact, I didn't do that. They gave the answer, then I had to try to figure out why. But whenever you give up, I'll give you a clue.
See, the displacement of the boat. The boat weighs less when you take the rocks out, but the rocks go into the water. See, if the boat weighed less, it would cause the boat to ride higher on the lake, which would raise the water level, which would lower the water level. But if you threw the rocks into the water without the boat, it would displace more water, and therefore the water would rise.
So it stays the same.
So one of those factors causes it to rise. One of those factors causes it to lower. And what you're saying is they don't cancel each other out. One of them is more greater than the other one.
Remember back to science class, what was the Raleigh theory? Do you remember the Raleigh theory? Well, what was the Raleigh theory?
Well, it wasn't a...
Well, tell me now, so you forgot.
No, I don't remember. This, of course, then there's the thing of density.
There you go.
Is that things will rise in terms of displacement and weight up to where the boat will displace the same amount of water that the contents weighs. If you were to take the displacement of the water that the boat was displacing and weighed that much water, it would be equal to the weight of the boat plus the load in the boat.
Exactly.
But okay, so in that terms, the rock is displacing at that point the amount of water that would weigh the same amount as the rock.
Exactly.
But if you throw the rock into the water, it displaces only the amount that the rock actually weighs. So since water has lower weight per gallon than a rock does, it would now, I got on the right track here. The rock in the water displaces less water than the rock in the boat. Right. Therefore, is less, so you're pushing up the water a smaller amount now, so therefore the water level would lower. Right. Okay, that's my answer.
Dad, what about if you fill a glass with
This has been brought to you by Raleigh and Bruce.